So in this example, we're asked to calculate the volume of solution required to reach the equivalent point. So we're told that we have a standard strontium hydroxide solution with a pH of 13.500. What volume of that would be needed to neutralize a 25.0 ml sample of 0.423 molar hydrochloric acid. And so I've written out my equation here, and reminder that since strontium hydroxide produces 2 hydroxide ions, I'm actually going to react in a 1:2 mole ratio here. I need 2 moles of hydrochloric acid to neutralize 1 mole of strontium hydroxide. Okay, so first I'm going to calculate the number of moles or millimoles of hydrochloric acid, because that's what I'm given the concentration and the volume of. So if I want to figure out the moles, I need to know the volume and the concentration. So my millimoles of hydrochloric acid is going to equal 25.0 mils times 0.423 millimoles per milliliter. And again, I'm just using that so I'm not having to convert from milliliters to liters and back a bunch of times when solving. Okay, and so at the equivalence point, I know that my moles of hydronium are going to equal the moles of hydroxide ions. So that means that my millimoles of strontium hydroxide is going to equal 10.58 millimoles of hydrochloric acid, and I'm going to use my mole ratio here, 2 moles of hydrochloric acid to react with 1 mole of strontium hydroxide. Okay, and so that's equal to 5.290 millimoles of strontium hydroxide. Next, we're given the pH, and so the pH is going to allow us to determine the hydroxide ion concentration in the solution. So if I want to figure out the hydroxide ion concentration, that's going to be 10 to the negative POH. Okay, and so that's going to be 10 to the power of negative 0.500. Right, that's the POH, not the pH. So 14 minus 13.500 is where that's coming from. Okay, so a reminder that the POH is 14 minus the pH for 25 degrees Celsius. Okay, so that works out to being 0.3162 molar hydroxide ion concentration. Okay, and so because each strontium hydroxide produces 2 hydroxide ions, that means that my concentration of strontium hydroxide should be half the concentration of the hydroxide ions. So the concentration of strontium hydroxide is going to be 0.3162 divided by 2, since each mole of strontium hydroxide produces 2 hydroxide ions. So that works out to being 0.1581 millimoles per milliliter. And so then finally I can convert I have my millimoles of strontium hydroxide here, and I've got my concentration, which I've determined here from the pH, and I can use those to now determine the volume of strontium hydroxide. So my last step, I'm going to take my volume would be 5.290 millimoles of strontium hydroxide multiplied by 1 mil is 0.1581 millimoles of strontium hydroxide. And so that works out being about 33.4 milliliters.